dy dx minus 3y over 2 equals 2y cubed e to the x. Let's make the substitution. Let v equal y to the 1 minus n then. The n, everything's arranged in the correct positions, correct arrangement. So the n is 3 here, isn't it? So that's y to the minus 2, which equals 1 over y squared if we wish. So let's differentiate then. dv dx will equal minus 2y to the minus 3 multiplied by, differentiate this, there's something differentiated, so we get dy dx, a function of function rule. So there's dv dx. Now rearrange it for dy dx. So dy dx then is equal to, this is a y cubed underneath, isn't it? So I'm going to move it on top. It becomes a y cubed there with dv dx. And this minus 2 can come down to go underneath here on the other side. So I'll put the 2 underneath, but the minus can just go there, can't it? So there's dy dx. So substitution then gives, so what do we get? Dy dx is equal to this. dv dx minus 3y over 2 equals 2y cubed e to the x. Now we can divide by y cubed all the way through and put in the value of v. So let's divide by y cubed. See what we get. Minus a half dv dx. And then we'll get minus 3 over 2. And we're divided by y cubed, so it's 1 over y squared, which we can replace by v, can't we? Because v is 1 over y squared. So I'm going to put that in straight away. Is equal to, dividing by the y cubed just leaves 2e to the x then, doesn't it? Now we'll times by minus 2, so that everything can be arranged correctly. Times that by minus 2, we get dv dx, which is what we want. Times this by minus 2, it becomes a plus, and there's just a 3 left then with v. And then times this by minus 2, we get minus 4e to the x. Nice easy little problem to do with the integrating factor method. Here's p, so we can work out the integrating factor. So here, I equals e to the integral p, which is 3, dx, which is equal to e to the 3x, isn't it? So there's our integrating factor. Multiply through by that then. So we get e to the 3x dv dx plus 3, I'll put it in the middle, e to the 3x times v equals minus 4 e to the 3x times e to the x. You add the powers, so you get 4x. Times you add the powers. So we get this. Circle u and v. Here's u. Here's v. And now let's write du by dx of u and v. E to the 3x times v is equal to then minus 4 e to the 4x. Integrate then, both sides. So we've got this problem now. So it's just a matter of integrating this. With respect to x gives, so integral of this side is 3x times v. And we've got the integral of this, minus 4, put that out the front, e to the 4x dx. And that equals then minus 4 lots of, and this will integrate to e to the 4x over 4. Plus k, which equals minus, the 4's cancel, e to the 4x plus k. There we go. So what have we got then? Last part of the problem then. So e to the x times v, e to the 3x times v, and v was 1 over y squared, wasn't it, at the outset of the problem? Let's just go back and check that to make sure we're happy with that. Go up to the top here, and we should be able to find out what v is. There it is there. V equals 1 over y squared. So I'll put it back in down here. So this is where we are. So e to the 3x over y squared, I've put that in there, is equal to minus e to the 4x plus k. Invert it. So this implies then that y squared over e to the 3x will equal 1 over this thing here, which I'll write the other way around, k minus e to the 4x, because it's easier on the I. And then we can move the e to the 3x up from divide to times on the other side. There we go. And now let's square root both sides. So y will equal then the square root of plus or minus, it's e to the 3x all over k minus e to the 4x. There we go. And there's the final answer.